Hi math students, it's Miss Carol again. Hopefully you appreciated being able to skip lesson 22 projects as there were no questions there. We are back for Unit 5, Lesson 23. We're still working with exponential functions and we have 5 questions in this assessment. So we're still dealing with this high school that's been exposed to the flu and a principal trying to relay that information to families. So question 1, we have in one day 2 students come to school infected and 10 students stay home sick. Remember, each infected person is able to infect 5 new people per day. Knowing this information, the principal defines the function f of x equals 2 times 5 to the x power plus 10 and its graph. Okay, so this is our initial graph. This graph can be translated using the mapping statements f of x going to f of x plus k, or f of x going to the quantity f of x plus k. So there's kind of 4 ways to do this, if you add and subtract vertically or if you add and subtract horizontally. So we will try and match each of these up with the respective mapping functions. So if I'm given f of x and I'm mapping it to f of x minus 4, a little hint that I like to remember here is that if this is a negative in here, we're going to move to the more positive side. We're going to kind of go opposite of what we would intuit here. So if we have f of x minus 4, we're actually going to go plus 4. All right, so our initial value here was 0 and 12. We're going to go 4 units to the right to 4 and 12. We're keeping that asymptote at y equal 10. So this is going to go right here. Oh, doesn't want to match up. Oh, that's strange. There we go. Okay, so that's our first one. Second one, now this is the function plus 4. So when the number is not inside those parentheses, that implies a vertical shift. And these are exactly. So if it's plus 4, you go up 4 on the y-axis. And if it's minus 4, you go down 4 on the y-axis. So in this instance, we're adding 4. So we should be going from our asymptote of y equal 10 to an asymptote of y equal 14. So this one comes down here. Let's get that to highlight. Ah, did it do it? It did. So, and then the initial value there would be 0 and 16. Okay, so now I have x plus 4. So remember, when they're inside the parentheses like this, we're going to go opposite, and I'm going to move to having my asymptote still at y equal 10, so I'm not moving vertically at all, but I'm moving that value to a negative 4 and 12. So those are going to match up there. And then last but not least, remember, if the value is outside the parentheses, we're going to go down, or we're going to follow the sign. So this is a negative sign, we're going to go down. Last time it was a positive sign, we went up. So we went from y equal 10 to y equals 6 here. Okay, so, yep, match up. Okay, question 2. If the principal finds out that 4 out of the initial 10 students who were homesick did not have the flu, which translation of the pre-image f of x would represent that new function? Okay, so we can kind of go look at this. Initially, we had that asymptote at y equal 10, and so our initial value here was y equal 10, but then and that 10 represented the students who stayed home. So now, and we assumed that all 10 had the flu. So now if only 6 of those had the flu, we could move this down here to this graph right here. So f of x minus 4. And our initial value there would be 8 instead of 12. Okay, so let's see. So it's going to be that f of x minus 4. It's important that you have the minus and that it's not inside the parentheses. And then the image is 4 units below the pre-image. Okay, so these two right here. All right, so we shifted down 4 units. What is a horizontal asymptote of the image of the translation we identified in this previous question? So let's just go quickly look at that graph. It's right here. This is the f of x minus 4 graph. That horizontal asymptote, and this is actually what we discussed in lesson 21, that horizontal asymptote is there at y equals 6. Okay, and what that's saying is no matter how big or small x is, our y value will never actually get below or even to y equals 6. It'll get very, very close to y equals 6, but it'll never quite get there. And if you're curious on that, I demonstrated that in the lesson 21 video. Okay, what is the initial value of the function in that image? So we can go look at that graph one more time, and we see that when x is 0, our initial value is 8. So we can just type in 8 here. Okay, and our last question, what would it mean if the original function f of x needed to be translated by the mapping statement f of x to f of x plus 3? Describe a situation in the context of this problem that would require this translation. So just like when he found out that 4 of those students didn't have the flu, if we mapped a plus 3, that would mean an additional 3 students stayed home with the flu. So plus 3 would, actually I'm going to write it like this, f of x plus 3 would indicate that an additional 3 students stayed home with the flu. Okay? Oops, not flea, flu. All right, so this was a pretty quick video, but hopefully you're understanding how to move these exponential functions around or how to map them. And I will be back here for lesson 24. Thank you for joining me.